Okay. Okay, that's all from the your own ufunc, yeah. So you can create your own ufunc method. Okay, we can go to the next slide. So the next one is working with Boolean arrays. Given a Boolean array, there are a host of useful operations you can do. To count the number of true entries in a Boolean array, you can use the np.count non-zero function. So for example, I will create a random numpy variable which has 10 size and also 3 times 4 shape, yeah. So the 10 is not the size, but actually this is the number of the range of the item number will be from 0 to 9, yeah, because we will randomizing the number from 0 to 9, and the size of this text variable will be 3 times 4, and the shape also will be 3 times 4. We have 3 rows and 4 columns. So let me type the code first. But actually this is we don't use the random sheet, yeah, but yeah, we can just using the random sheet. Remember, if we want to randomizing the item inside the numpy, and we want that the number will be the same, yeah, every time we executed it. So we can just using the np.random.sheet like this. So we can just using the 0 parameter. Then we create x variable, x equal np.random.rand integer, and the range comes from 0 to 9, and the size, we set the size as 3 times 4, and we can just print it first. We just want to know the number inside the x variable. So this is different with the output from the slide, because on the slide we don't use the np.random.sheet, but it's okay. We can just use our x numpy variable. So then after that, we can count we can just count the item inside this numpy variable which has some condition. So for example, we want to count the item inside the x numpy variable which is less than 6, right? If we just use this code, then if we look at the output of this numpy variable, we can just count it by ourselves, because there are 8 numbers below 6, yeah. Okay, there are 8 numbers below 6. So for example, we want to count the numbers which has some condition. We want to count the number which some condition. So for example, we can just use this code np.count underscore non-zero, np.count, and we can just print it, print np.count underscore non-zero. Then inside this round bracket, we define the condition. We want to calculate, we want to count the number that is below from 6 or less than 6. You can just use this statement x less than 6. So it will be, yeah, it will be around, yeah, it will be 8, yeah, because there are 8 numbers which are below from 6. Okay. Other than that, we can also use np.sum like this, print np.sum, and we can just set the condition inside the round bracket like this. It will be also 8. So if you want to calculate, if you want to count the number which some condition, we can use the count underscore non-zero or sum method. Okay, That is the counting entries. And the benefit of sum method is that, like with other Numpy aggregation function, the summation can be done along rows or columns as well. So we can also use the sum. Yeah, the differences between sum and count on zero, it comes from the sum also has the second parameter, and the second parameter represent the axis. Yeah, it is useful if we use the multidimensional array, right? Because we are working with the two-dimensional array, we can just use the axis parameters, and we can use the axis parameter if we use the MP the sum. Because count on zero, we don't have the second parameter which represent the axis number. So for example, I will add another code here. Then we can just copy this code and adding the axis parameter. So axis parameters, remember, axis parameter represent the rows or the column. If we want to calculate the number of if you want to count the number that is below from 6, yeah, by its rows or by its column, we can use the axis parameters. For example, we have two axes here because we have two-dimensional array. We have axis 0, which represent the the axis 0, which represent the rows, and axis equal 1 represent the column. Okay, so we add axis parameter like this. Oh, there any error? Wait, axis is invalid keyword for print. Oh, I'm sorry. I put this parameter outside the sum method, right? So actually, must be like this. Yeah, for 2 and 2. Axis equal 1, it means we count the number which is below 6 by its column. Sorry. Axis equal 1, it means we calculate we count the number which is below 6 by its column. Yeah. So for example, this one, we have wait a minute. I will MP dot sum is equal 1. Wait a minute. In each row, yeah, it will be 4, 2 and 2. This one we have 3 actually, yeah. 2. Okay, yeah. This one we have 6. We have 4 numbers which is below from 6, yeah. 5, 0, 3 and 3. We have 4 numbers below 6. And 7, 9, 3, 5. We have 2 numbers below 6. And 2, 4, 7 and 6. We can also have 2 numbers below 6. Right? But if we use the axis equal 0, so we will count it by its column. So axis equal 1, it means we calculate it by its rows, yeah, vertically, yeah, sorry, horizontally, and axis equal 0, we count the number which is below 6 vertically, right? Okay, 0, it means we calculate it, we count it by its rows, by its column, yeah. Axis equal 0, we will count the number which is below 6, yeah, by its column, and axis equal 1, we calculate it by its rows. Okay. Because the shape of the x numpy variable is 3 times y x shape. Okay, 3 times 4, we have 3 rows and 4 columns. Okay, if we set the axis into 1, so we count the number which is below 6 by its rows, right? By its rows horizontally. But if we use the axis equal 0, so we count it by its columns or vertically. Okay. Okay. If we interest in quickly checking whether any or all the values are true, we can also use the np.any or np.all. So, for example, I will add another code here. You can just use the np.any. np.any, so it means we only have two types of output, true or false, right? True or false. So it means if there are any number which is below, for example, not below, greater than 8 in our Numpy multidimensional variable, so it will have the output as a true. So for example, np.any x greater than 8. So inside our Numpy variable, because we have two-dimensional array variables, so we don't need to consider by its rows or column, right? Because this output will be true or false. Because there are a number which is above 8 or greater than 8 in our x Numpy variable. That means it will give you true value, right? We can also use the np.all. Yeah, it's the same with np.any. But if you interest to know the differences between np.any and np.all, you can just open the documentation from the Numpy official website. But actually, if we follow the slide, yeah, np.any and np.all has the same function because we only have, np greater than 8. If are all values less than, are all values less than 10, yeah, it's different. All of the values is greater than 8, yeah, it's false. If any, is there any numbers or is there any items inside our x Numpy variable greater than 8, yeah, it's true. And the differences between np.all and np.any, np.all are all the items inside our x Numpy variable greater than 8? No, it's false because there are some numbers such as 9, yeah. Yeah, there is one number, and there is one number 9 is below 8, greater than 8, right? So yeah, there's differences between any and all. But actually, we can also use the np.all with axis parameters, yeah. Axis parameter. So you can just add another code here, and we can count it or we can find the number which are below or greater than 8, yeah. So this example we use the greater than, yeah, the greater than 8 by its axis, yeah. For example, we use the axis as 1. Yeah, it should be inside the round bracket of the any method, yeah. Okay, false, because we count it vertically, yeah. Horizontally, because x is equal 1, we use the x-axis, yeah, not y-axis. If we use the 0, it means we use the x-axis. Yeah, it's just some function in Numpy. Maybe in the future you need to use that. Yeah, you need to use them. Yeah. So you will use them after you work on real case, yeah, on real case study. So yeah, that's all from the functioning entries. Before we go to the fancy indexing, is there any question? Do you have any question? Yeah, it's clear. Okay, you can just, yeah. Any question? Cannot? No?
No, sir. No.
Okay, okay. Yeah, so we can continue to the fancy indexing. So fancy indexing is fancy indexing is like the simple indexing we've already seen in Python list or also in Numpy variables, that we pass arrays of indices in place of single scalar. So it means what we have done before for the indexing, we only use the scalar numbers. So we use the scalar numbers inside our square bracket, yeah, for accessing the item inside our Numpy variable. But actually, we can just use the list inside our square bracket arrays, yeah. So this allows us to very quickly access and modify complicated subsets of an array values, yeah. Because what we have done before in indexing in list and also in Numpy, what we have done in the last week, yeah, we only use the scalar number inside our square bracket, yeah, when we indexing the item, the Numpy variable. Fancy indexing is conceptually simple. It means passing an array of indices to access multiple array elements at once. So for example, yeah, we can just follow the code. This is slide. We create a x variable np.random.ramin like this. Then inside this round bracket, we have the range of the number which will be randomized inside x variable is between 0 to 99. Then after that, the size of this number variable, we can just set it as m. So it is a one-dimensional array. Yeah? Then after that, we want to know the number of the item values inside x number variable. Yeah, it will be 88, blah, blah, blah. Okay. So, yeah, we can use the empty random list, yeah, because I don't want every time I execute this code, the item values will have a different number. So I use the empty.random list. So these are the numbers which is randomized inside x variable. Then after that, yeah, we add another code here. We set the index, yeah, in the index. So I create a variable ind equals 3, 7, and 4. I want to get the item values in index 3, 7, and 4. So this list will be the index in our Numpy variable. Okay. How to use this list as an index? Yeah, we can just print the x Numpy variable, then the index inside this square bracket, you can just use the ind variable like this. So after that, if I execute this code, so I will get the item value in index 3, yeah, index 3, index 3, yeah, this one is index 3, index 7, 3, 4, 5, 7, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, then index 4, which is also 67, yeah. So this is the way how to use the list index inside our Numpy variable. Okay. Yeah, we can also try another code here. For example, with fancy indexing, the shape of the result reflects the shape of the index array rather than the shape of the array being indexed. Yeah, so it means if we use the the index, yeah, like this, then np.array. So we create another index list here. So the index list is not a list, it's not Python list, but Numpy variables. For example, I create a two-dimensional array, yeah. So this one is two-dimensional array. np.array, and then inside this array, we create another array, another list here, 3 and 7 and 4 and 5. Okay, so this is a two-dimensional Numpy array. Yeah, remember, if we create a two-dimensional array, you can use this code. So this one is creating two-dimensional array, custom Numpy variables. Yeah, we have 2 rows and 2 columns. Yeah, 3, 7. The first rows will be 3 and 7, and the second rows will be 4 and 5. So you can just print the IND variable first. Yeah, these are the two-dimensional array, and the set will be 2 times 2. So we can use this IND variable as an index. Yeah. So for example, we have this one. Yeah, we have this x. Yeah, we have x variable. What if we use the IND as an index inside our x variable? Okay, we can add another code here. Okay, print x and the index. I will use the IND variable. Okay, so what does it mean? So after we indexing the x variable using two-dimensional Numpy array, the output will also follow the shape of the index. Yeah. So it means we want to get the index 3, index 7, index 4, and index 5. Yeah, you can just check it. Yeah, index 3 it will be 67, index 7 will be 21, and so on and so on. Then the output of the x variable, which is indexed by the two-dimensional array, will be also has the same shape with the index. So yeah, 2 times 2. Okay, fancy indexing also works in multiple dimensions. Consider the following array. For example, we create another variable x equal np.arrange 12. So we create two-dimensional array which has 3 rows and 4 columns, and the range item, the item value has the range between 0 to 11. Okay, so we can just follow the code. Right, x equal np.arrange 12 and reshape 3 times 4, 3, 4. Okay, so like with standard indexing, the first index refers to the row and the second to the column. So for example, we create another code here. We have a row variable equal np.array, and yeah, we create another variable row which has 0, 1, and 2 items, and column. And for the column, you can just copy it, column. So I set the item inside the column as 2, 1, and 3. Okay, then we can use these two list or these two Numpy array variable as an index for x. Yeah, so if we print x with row and call index, right, row and call index. Okay, with X row and oh sorry, this one is not column but row and col. Yeah, it will be 2, 5, and 11. Why we get this item? Yeah, because we have row and col, right? We access the row, yeah, the row of X, yeah, 0, 1, and 2. 0, 1, 0, 0, sorry, 0, 2, yeah, 0, 2, we get this 0, 2, this one, yeah, this one, the item of the ix, yeah, x variable, this one, 2, yeah, 1, 1, so we get this one, 5, and 3, 2, 3, 2, 3, 2, 3, this one, yeah. So we can also use two Numpy array variable as a row and column index here. Okay. So this is the way if we use the Numpy array variable as the index here for multidimensional Numpy array. Yeah. And we can also experiencing with another example here. Yeah. Yeah. Let's go to the next slide. Notice that the first value in the ratio is x, 0,2, yeah, 0,2, 1,1, yeah, like I was mentioning before. And if we get a two-dimensional result, yeah. Okay, so for example, we have another example here, yeah. So we can just another. So yeah, print x row, yeah, row. So it means we use the row, we use the row Numpy array, yeah, we use the row Numpy array here, and x row. Then inside the row Numpy variable, we can also use regular indexing, yeah, using, for example, column. Yeah, for example, this one we use the column and comma and p dot new axis. Okay, wait, I will explain to you after this. So let me type the code first. Okay, if you combine a column vector and row vector within the indices, we get a two-dimensional result. So for example, this one x row, yeah, we use the row variable, and we get all of the rows inside the row. That means 0, 1, and 2, comma np dot new axis. What is it? Wait a minute. This one is represent with 0, 2. The output will be 2, 1, 3, 6, 5, 7, 10, 9, 11. Okay, 0, wait. I forget about the np dot new axis. So what is this function? Wait, let me remember it first. Maybe you have any idea of this? Wait, I forgot about this. np dot new axis, so it means wait, np dot new axis. What is this function? Let me check on the new axis. Okay. NP.new axis, it means it's used to increase the dimension of the existing array by one more dimension, because the row is a one-dimensional array. If we use the NP.new axis, so it means it will change to a two-dimensional array. Yeah. 0 to 0 to 6 4 2 6 and 4. So it means 2 6 and 4, 0, 2, 0, 1 and 0, 3. So if we use this two, okay, let me check it first. Yeah. Okay, this one is the okay. Let me check it first, yeah, because we have limited time. So I will back on this code, yeah, after this. So let me check the documentation first. I will back to you after I found the explanation about how should we use the NP.new access, yeah, because I forgot about this function NP.new access, but I will back to you after I find the solution. But if this purpose, we can just go to the next one. Yeah, for even more powerful operation, fancy indexing can be combined with the other indexing scheme. Yeah. For example, we can combine fancy and simple indices. Yeah, we combining this one is the list. Yeah, and also this one is the regular index. Yeah, and we can just follow the code. Print x 2 comma inside this one. Yeah, for the column. Yeah, this one is the represent the column. We use the column 2, column 0, and column 1. So the output will be 10, 8, and 9. 10, 8, and 9. Yeah, because we use the row 2, yeah, row 2. Then after that we get the column 2, yeah, column 2. It means 0, 10, yeah. Column 0 we get 8, and column 1 we get 9. Yeah, so it means we have an item with the index 2, 2, 2, 0, and 2, 1. Yeah, like that. So yeah, we can also use another example here. We can just add another code. Then we change the row indexing as a one column, yeah, like this. So it means we get all of the rows start from row 1, yeah, 4 and 8, yeah, 4 and 8. So it will give you a two-dimensional array. Why? Because we get the two-dimensional array because we have 2 rows, right? This one is on the rows. We get the value from index rows index 1 and index 2 because we have 3 rows here. From the index 1, yeah, start from index 1, we get the value inside this x variable, which is 1, 2, 1, 0, and 1, 1, and also 2, 2, 0, and 2, 1, right? So 6, it comes from index 2, index 1, 2. 4 comes from index 1, 0, index 1, 0, it's 4. Yeah, this is from the rows 1 and 0 column. And the 5 numbers is get from the index 1, yeah, rows 1 and column 1, this one, right? So yeah, that are the example of the fancy indexing. Yeah. So you can playing around with the indexing with your experiment, yeah. So as usual, in the end of the meeting, yeah, of the meeting. So you will get another homework, yeah. So you will try by yourself how to use the fancy indexing, yeah. But I will also find the solution about the NPW axis, yeah, this one. So I will give you if I cut, yeah, if I have gotten the explanation about new axis, yeah. So that's all from, yeah, we still have another slide here. Modifying values with fancy indexing, yeah. Just as fancy indexing can be used to access parts of an array, it can also be used to modify parts of an array. For example, imagine we have an array of indexes and we'd like to set the corresponding items in an array to some value. So for example, we have a x variable, we fill this numpy variable with 10 items, yeah. I'm sorry, not 10 items, but wait, we can just follow the code, yeah. So you don't need to be confused. X and p dot range 10, yeah. And just print it first. Yeah, we have 10 values, yeah, inside the x numpy variable, which the range is comes from 0 to 9. Then we also have the I variable equal and p dot array. So the I also the numpy array variable, custom array variable, which has one-dimensional which is one-dimensional array. Yeah? So 2, 1, 8, 4, like this. And you can also use the x with the index e like this, yeah, because we want to indexing the numbers, the array variable or the numpy array variable, not only indexing but also we can also use the fancy indexing for modifying the value. So for example, I want to change the value in index 2, index 1, index 8, and index 4, yeah, inside the x numpy variable, yeah, with 99 values. So if we execute this code, so the index in index 2, yeah, the value in index 2, index 1, index 8, and also index 4 will be changed, yeah, to 99, right? So not only getting the item from the numpy variable, but also we can also use the fancy indexing for modifying the values inside our numpy variable. And we can also use the any assignment type operator for this. For example, yeah, you can just add another code here. X with index e, yeah, we change to equal minus equal 10. So it means the value, yeah, the item value in index I, yeah, will subtract, yeah, will be subtracted by 10. Yeah. So for example, this one, wait, I forgot to finish. So this one will be 89, yeah, 89, because the values inside our x numpy variable will be subtracted by 10, right? Yeah, that's all for the fancy indexing. Before we go to the sorting, searching, and filtering, do you have any questions?
So there is no no sir. I mean I want to ask.
Yeah. Okay.
There is no minus negative number.
Minus negative number. So what does it mean? Minus negative number. So it means
yeah, I mean
like
minus
this?
3 minus 10 is supposed to be minus, like,
oh, okay,
you know,
yeah,
you say that it will be subtracted by 10, right? But the 3 and the
yeah, that's right. So yeah, you mean if we add minus 10 like this, so it will be added by 10, not subtracted by 10. You know. Yeah, you mean that? You mean like that?
Yeah, I mean the result of the subtraction, if we have
Oh,
the,
okay.
for example,
Okay.
the index 3 on that array is 3, subtracted by 10, it's still 3.
Okay. Oh, yeah. Okay. So for example, this one I add another code here. So I copy this. For example, because the maximum value of the item inside our x variable is 89. What about if I subtract it by 100? Yeah. So it will be minus 11. Yeah. Print x. Yeah. Yes, possible because this one, if we create a numpy variable x, the data type will be integer 64, right? Integer 64. So integer 64, it means we have the minus range, yeah, because we have integer, not unsigned integer. If we set as an unsigned integer, so the value, yeah, the value will be not minus, because the range of the integer from the minus I forget, yeah, the range from the integer 64. But actually, if you set or define the number with the integer data type, yeah, you can have a minus number. But if you have the unsigned integer, so you will not be able to have a minus number, because by default when we create a numpy variable, it will have the integer 64 data type, right? So for example, this one I want to know the data type, yeah. The type, it will be integer 64, yeah, because this one, yeah, you can just find on the Google the range of integer 64, yeah, integer 64 from minus, yeah, from minus, wait, from minus 9 billion, yeah, sorry, if I'm not mistaken, minus 2 the power of 64, not mistaken, yeah. This one is the range from integer 64 values. But if you set the data type as unsigned integer, so it will be not a minus number. But yeah, I also curious if what about if we set another number here, then yeah, we set the np.range and the data type will be unsigned 64, yeah. Okay, wait. The type is not defined. How to define the numpy with unsigned integer, yeah. Define the numpy as u. The type u in a. The type u in. Wait, what if I change this one to a? Okay, it's not defined. Wait, what about if we create a custom numpy array, yeah? For example, this one, 1, 2, 3, 4, 5, yeah, and the type equal unsigned integer 32, for example. Wait, why we cannot use the unsigned integer? Because we need to add another bracket here. Okay, wait. How to define how to define, how to create Numpy unsigned type. Okay. Well, wait, let me copy this code and another code here. X equal Numpy array 1 2 3 type float. Okay, it works if we change to unsigned. Oh, okay. I think we need to give, what is it called? Quote, yeah. Quote mark, yeah. Okay, yeah. So yeah, for example, like this, then if we want to subtract the item with 10, for example, yeah. So for example, we add another code here. So this one, let's copy this I variable, and we change to, for example, yeah, 0, 1, and 2, because the maximum index is 2, yeah, because we have one dimensional array and the index is 0, 1, and 2. Then we can another code here, x index I minus equal 10. So what will happen, because this data type, yeah, of x is unsigned integer, not integer, right? So we have we will not able to have minus values, right? Yeah, yeah, we cannot use it because the index x is out of bounds for axis 1 and with size 3, right? Wait a minute. Let me check it first. Yeah, we cannot use it because index x is out of bounds for axis 0. Wait. Oh no, I have not expected this too. Okay, yeah. So if we print the x values, yeah, let's see what happens. Yeah, we don't have the minus number, right? So I don't know why the output will be this value, but if we want to know the range, yeah, the range of unsigned integer, this one, yeah. So if we just copy, it's around 4 billion blah blah blah, yeah. So my guess is, I'm not sure, but the best guess that I can say that because the unsigned integer will not be able to be a minus value, so it will change the value to the maximum, right? The maximum. It will back to the maximum value. But I'm not sure about this. Yeah, the best case that I can say to you is, yeah, it will go back to the maximum value, right? Yeah, you can just copy it. Let me see what is the difference between this one is maximum value, right? And if we subtract the 0 by 10, and the result will be this number, right? 87. I don't know why we can get this number, but actually maybe it will go back to the maximum value, then subtract it by 10. Yeah. But actually I don't know why this number comes. Yeah. But it's like it come back to the maximum value, then yeah, decreasing the number. Okay. Yeah, maybe that I can answer. Cannot.
Yes, sir. Thank you, sir.
Okay. Yeah. So do you have any question? Do you have any other question maybe before we discuss about the sorting, searching, and filtering? Okay. We need a break. Yeah. We need a break for 10 minutes. Yeah. We will go back at 11. Then we will discuss about sorting, searching, and filtering. Okay. If you have any questions, you can just type on the chat box. Yeah, the question.
Okay, let's continue to the next slide. Yeah. Do you hear my voice? Sorry, I changed my microphone because I have a problem with my previous microphone. Do you hear my voice? Can you confirm it?
Yes, sir.
Okay. Okay, it's clearly. Is my voice clear or not? Sorry, clear, yeah. Okay. 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 Yeah. Thank you. So we continue to the sorting, searching, and filtering. So actually, if we build our own algorithm or method for sorting an array in NumPy array, so we can just use this code, yeah. So this is the example of the selection sort. We can use this algorithm or this code for manually sorting the array, not the NumPy array. But yeah, there are some limitation if we use the selection sort method, yeah. So if we build our own algorithm for sorting the NumPy array, the item inside our NumPy array, there are some limitation. Yeah, the limitation are, yeah, the selection sort is useful for its simplicity, but it's much too slow to be useful for larger arrays. So the selection sort, yeah, the algorithm for the selection sort is it's work on the small data, but if we have a large data, so it requires a high computational time. Yeah, for a list of n values, if we have n values inside our NumPy array, it requires n loops. Yeah, for example, we have 1 million data in our NumPy array, so it will require 1 million loops. Yeah, each of which does on the order of n comparison to find the swap value. Because yeah, maybe you have learned about the selection sort, or maybe in structure data structure. Yeah, you learn about how the selection sort work. But actually, this one is the example of the selection sort. We need to swap each values. Yeah, we need to doing the loop in n times. Yeah, for example, 1 million. So if we have a 1 million data, so it will require 1 million loops. Each loop we need to doing the swapping process. Yeah, for swapping the numbers, because we want to sort it. So the swapping is just a method for, yeah, for sorting the numbers inside our NumPy. Yeah. In terms of the big O notation, often used to characterize this algorithm selection sort, for its big O n square. Yeah, so it means, yeah, it's not good computational time, because we need the big O n square. If you double the number of the items in the list, the execution time will go up by about a factor of 4. Yeah. Although Python has built in sort and sorted function to work with the list, we won't discuss them here because NumPy np.sort function turns out to be much more efficient and useful for our purposes. So you don't need to build your own sorting algorithm, yeah, or maybe you can actually create an algorithm, yeah, based on some of the sorting algorithm like selection sort, quick sort, double sort, and something like that. But actually, if you use a NumPy for NumPy arrays, yeah, we can use the sort function. Yeah, it's more efficient and effective. The sort function also the ufunc, yeah, because the ufunc, yeah, like I was mentioned it before, this function is much more efficient and effective if we compare with the sort function from the Python, or if we build our own algorithm for sorting. So I recommend you, it's recommended if you use the np.sort function. By default, np.sort use unbig O n log n and quick sort algorithm. So by default, yeah, the np.sort use the quick sort algorithm. To make sort or heap sort are also available. Yeah, we can just use the quick sort. We can actually we can choose which algorithm that we want to use. Yeah, we can use the quick sort or make sort or heap sort. Yeah, but by default, yeah, the quick sort algorithm will be used if we use the np.sort function. For most applications, the default quick sort is more than sufficient, yeah, because the quick sort is, yeah, it's much more efficient. Yes, it's sufficient to sorting some of the NumPy variables. For example, we have x variable, x equal np dot array, and then inside our x variable we have around 5 items, yeah, 2, 1, 4, 3, and 5. Then after that we can just call the short function, and the parameters we set to, yeah, the x, yeah, so the output will be 1, 2, 3, 4, and 5. Yeah. So yeah, we can just follow the code. Next slide, we create a NumPy array. Then inside our NumPy array we have a list. This is the random list, yeah, 2, 1, 4, 3, and 5. Then we want to sort this NumPy variable, so we can just call np.sort with x parameters. So it will be 1, 2, 3, 4, and 5. Yeah. A related function is argsort. Yeah. What is argsort? Yeah. With argsort, it means we return the index values. Yeah. So I mean, if we have this NumPy variable, then we use the argsort. Yeah. It will return the index. Yeah. Not the values, but not the item values, but also, but it's only the index. Yeah. So you can just try it. It will be 1, 0, 3, 2, and 4. So what does it mean? It means 1, yeah, because the smallest value in our list is 1. 1 is located in 1 index, in index 1. Then the return value for the argsort function will be 1. And the 0, it means the index of 2 items. Yeah. 2 items. Two items is located in index 0. So it will give you the output as a 0 here. So the argsort, yeah, it means it will give you the return value which are the index of your item inside your NumPy variables, right? It's only the index, not the items values. Okay. Then yeah, the first element of the result gives the index of the smallest element, and the second value gives the index of the second smallest, and so on and so on. So it will give you the index, yeah, the index of each items, yeah, and the index of each items. If this item is already sorted, yeah, so it means, yeah, 1, it means we have 1 because 1 is located in index 1, and so on and so on. Okay. A useful feature of NumPy sorting algorithm is the ability to sort along specific rows or column of a multi-dimensional array using the axis argument. So yeah, we can just follow the code in our slide. So we create another x variable here, and np.random.randin, we randomize the item inside our x variables. So the range of the items which will be generated is from 0 to 9. Yeah. So we set it to 0 to 10 for the first and second parameters, and the third parameters will be the size of the shape of the x NumPy variable. 4,6. Then you can just print the x values here. So it will give you this number. Yeah. So yeah, I don't want every time I execute this code, I don't want if the item value will be changed. So I just use the np.random.shift with 0 parameters here. Okay. Then we create another code here. We want to sort, yeah, this NumPy variable by its axis, yeah, by its column or its rows. So we can use the np-sort function. We can still use the np-sort function. So for example, I will use the np.sort, yeah, sort, and the parameters, because I want to sort the x variable. So the first parameter will be the NumPy variable that we want to sort, and the second parameter is the axis here. So it means if we use the axis equal 0, so it will sort by its rows here. Sorry, it will sort by its column. Each column will be sorted, right, in increasing order, yeah, 3, 5, 8, 8, 1, 0, 5, 8, yeah, 1, 2, 3, 4, 3, 4, 6, 9, and so on and so on. And if you want to sort, yeah, by its rows, not its column, you can just change the axis value as 1. Yeah. So as you can see here, it will sort by its rows. So this one is the original rows, and this one is the rows after it is sorted. Yeah. Okay. What about if we don't use the axis parameters? Yeah, let's just try. Yeah. Wait. Yeah, let me see the differences between if we don't. Yeah. Okay. So by default, yeah, the axis value will be 1, because if we don't use the axis parameters, yeah, it will be set to 1. It will sort by its rows, not its column. Okay. So yeah, that's all from the sorting algorithm. Yeah, sometimes we're not interested in sorting the entire way, yeah, but simply wants to find the k smallest values in the array. And Numpy provides this in the np.partition function. np.partition function takes an array and a k number, yeah, and a number k. The result is a new array with the smallest k values to the left of the partition, and the remaining values to the right in arbitrary order. So for example, yeah, let me just follow the code in our slide. We have x Numpy variable, then we create an array, a custom array here, one dimensional Numpy array. Then we set the values to 7, 2, 3, 1, 6, 5, 4. So this is the one dimensional array. Then I want to sort this Numpy array, yeah, with a number of k. So it means we only sorting the k values of this Numpy array variable in the item inside our x Numpy variable. So for example, let me just print np.partition. Then the first parameter will be x and the second parameter will be 3. So it means we only sort the 3 numbers, yeah, only the 3 numbers, yeah. Okay, let me just take this code first. It will give you 2, 1, 3, 4, 6, 5, and 7, right? So what does it mean? Okay, let me check this code first. And we want to text an array and number of k. The result is a new array with the smallest k values to the left of the partition, and the remaining values to the right in arbitrary order. Okay, if we set to 3, so not the first 3 values in the resulting array are the 3 smallest in the array, and the remaining array position contain the remaining values within the 2 partition. The elements have the arbitrary order. So yeah, okay, if we read these 2 points, that means the first 3 values, yeah, it will be the 3 numbers, yeah, the 3 smallest number inside our x Numpy variable, right? But actually it is in arbitrary order. So it's not always 1, 2, and 3, but it is in arbitrary order. But the important thing, if we use the np.partition and we set the parameters of 3, the second parameter as 3, so we will find only the 3 smallest number inside our x Numpy array variable. So it means because we know that 2, 3, and 1 is the smallest number in our Numpy array variable. So it will be located on the 3 first index, yeah, in our Numpy variable after we use the np.partition. But it is not in sorted order. It is in arbitrary order. It will give you only the three smallest numbers, not in sorted order, but in arbitrary order. Okay, yeah, within the two partition, the elements have the arbitrary order. Okay, yeah, that's all from the sorting. Then we will go to the searching. Yeah. So yeah, we can search an array for a certain value and return the indexes that get a match. Yeah, to search an array, use the where method. Yeah, for example, yeah, let me just follow the code here. We have the array variable equal np.array, and yeah, we create a custom numpy array variable. Yeah, 1, 2, 3, 4, 5, 4, and 4. Then we have another variable here, x equal np dot where, and inside the where method we have a condition here, arr equal 4. Okay, let's see what happened. Print x comma 3. Yeah, we can search an array for a certain value and return the indexes that get a match. To search an array, use the where method. So okay, let me execute this code first. Okay, so we want to know the the output will be 3, 5, and 6 as the same. 3, yeah, 3, 5, and 6. So it will give you a value of the index here. This is the index of the 4 number inside our arr numpy array variable. Yeah, because we have three 4 numbers. Yeah, we have 4 numbers. Then it is located on index 3, index 5, and index 6. Yeah, so it will give you the value. Yeah, the item, not the item, but actually it will give you the index value. Yeah, index value from the 4 numbers, for number 4. Yeah, so yeah, yeah, so it means it will give you the 4 the index which is the number of 4. Yeah, so 3, 5, and 6. Yeah, because we use this one. If we don't use these 3 numbers, it will give you only 3, 5, and 6. Yeah. Okay. Yeah. We can also have another example here. We can find the indexes where the values are even or odd by using the modulus calculation. Yeah. So okay, let me just copy this code. We create another code here, and we have 1, 2, 3, 5, 6, and 7. Okay, 6, 7, 8. Yeah, and x equal np dot where arr equal arr modulus by 2. Yeah, because we know that the number, if we do the modulus calculation of the number and we module it, the number with 2. So if we have the 0 number, it will be even number. Yeah. Okay, and for the y variable, we want to get the number. Yeah, we want to get the number, the index number of the odd numbers. Yeah, so this will be 1 value. Print y. So it will give you the index of the even numbers, and also odd numbers. We know that 1, 3, 5, 7, and 7. Yeah, it is located on index 0, index 2, index 4, and index 5. And 2, 4, 6, and 8, it is located on index 1, index 3, index 5, and like 7. So you can try by yourself. You can playing around with the parameters inside the where method, yeah, because this is the condition and the condition that you want to give to your numpy array variable, and it will give you the index, yeah, the index of the number that you want to search using the where method. Okay, there is a method called search sorted, yeah, which performs a binary search in the array and returns the index where the specified value would be inserted to maintain the search order. So, for example, we can also use another method here, search sorted. Yeah, for example, we have an array here. We have ARR equal np.array. Yeah, let me just follow the code in our slide. Yeah, we have 7, 12, 9, yeah, 9, and also 12 and 2. Yeah, we have this array variable, and we want to know the location of the new item. If we want to add the new item inside our ARR variables, so which the index should be located for the new item. So for example, we want to print np dot search sorted. So this one is the method that we will use. Yeah. Okay. Search sorted, then the first parameter is the numpy variables, and the second parameter is the new item. So what does it mean? If we have a new item which is 7, so if we want to add this item inside our ARR variables, so which index for the 7 item, yeah, for the 7 numbers? So it will be 0, right? Why 0? Because if we use the search short, we don't shop this ARR variable. But actually this one, 7, which should be located, it will be a 0. Yeah, it will be in index 0. Why? Because if we put it in this location, it's not true, because it should be in index 0, right? So it means the search sorted method will return the index where the specified value would be inserted to maintain the search order, right? We will not short this ARR variable, but actually if you use the search sorted, it will return the index where the specified value will be inserted to maintain the search order. So it will be located on index 0, right? Why we don't set this item with index 1? Because if we set to index 1, it also makes sense, right? Because it can be index 0 or index 1, right? Yeah. If you see in the next code, yeah, let me set another code here. We also have another parameters. If we set another parameters here, side equal right, so it means, yeah, it will give you a 1 index, because by default the side will be left if you use the search shortcut. But if you don't set the side parameters, it will be left. But if you give the set parameters, it will be, yeah, you can just change to the right, so it will be 1. Right? What about if I put the 9, yeah, the 9 variable? Anyone can answer my question? If I put the 9 value here, so which is the index that I will get if I execute the search method with the side right here? Anyone can answer my question? Nine. Which index should be which 9 index should be located? Okay. Let me annotate my okay. So 9 will be located in this index, right? Right. Why? Because we use the right, right? We use the right parameters, and if we put the 9 values in our ARR variable, it will be located at index 3, right? Okay, let me execute this purpose, yeah. It will be located, oh, sorry, 9. Why it's 5? 0, 1, 2, 3. It will be located in 3. Why it's 9? Oh, wait. And this one first. It should be 3, yeah. 1, 0, 1, 2, and 3. Wait, let me check my code first. Okay. It should be on 3, yeah, because we don't short this way. Okay. Let me remove the type parameters, yeah. Okay, you should wait. There is method called search shorter which perform a binary search in the array and return the index where the specified value will be inserted to maintain the search order. Wait a minute, I will find the explanation first why it is located on. If we use the equal. Okay, let me add another text here. So the right order will be 2, 7, 12, and 9. Sorry, 9, 12, and 12, right? Okay. The number 7 should be inserted on index 1 to remain the short order. The method starts the search from the left and return the first index where the number 7 is no longer larger than the next values. If we use the, okay, let me use a 2. If we look at it at 0, if we use the 11, why 11 is located at 5? If we use a 7, sorry, 9, 8, 10, 4. Okay, let me check on the documentation first, yeah. We'll go back to you about this explanation, yeah. So this one, 0, 0 don't have a clear explanation, yeah, but it's okay. I will go back to you to give you the explanation, yeah. Okay. Also this one, yeah. Which one? Do you remember which one that I need to give you a more explanation? Not mistaken, it's in fancy indexing, yeah. Okay, wait, I will go back to the previous slide. Yeah, that this needs more explanation. Oh, this one, yeah. Exploring the fancy index using bigger axis. Yeah, so this one also need more explanation from me. This one, yeah. I will go back to you to give you the more explanation. Okay, I will go back to you and give you the more explanation. Yeah, so because we have limited time, so I will go to the next slide first. Yeah, so actually this one that I understand. Yeah, I read the documentation in the Numpy libraries. Yeah, so actually this one is for getting the index. Yeah, the index of the number if we inserted the new values. But actually it's not really true, because if we use another number here, it will give you, yeah, for example, this one is 10, it will give you 5. Yeah, the index 5. I don't know why it give you the number of the index 5. Yeah, but actually if we use this 1 to 8, it will give you 1 and 9, it will also give you 1. Yeah, or 5. Yeah, okay. Let me check the documentation first, and I will go back to you to give you more explanation. Okay, we can just go to the next slide. So this one is filtering. Yeah, filtering is getting some elements out of an existing array and creating a new array out of them. It's called filtering. In Numpy, you filter an array using Boolean interface. So, for example, I just follow the code in our slide. We create an ARR variable equal np.array. Then we give we have some item here, 41, 42, 43, and 44. Then we create another Numpy array here. It's not Numpy array, but item list. Yeah, ARR. Sorry, it's not Python list. It's still a Numpy array, but x equal ARR with the index of Boolean index. Yeah, it will give you true, false, true, and false. Okay, this one is the ARR Numpy variable, but you give the index of true or false. So the index is a binary index, Boolean index. Yeah, and just call it as Boolean index or binary. It's the same. And if we print the x variable, it will give you number 41 and 43. Why? Because we set the first index, yeah, as a true, so we will get the number of index 1. It will be 41. And 43 will give you 43 because we set the index as true, right? Okay, the example for filter 41 and 43. Why? Because the new filter contains only the values where the filter array had value true. And in this case, the index 0 and index 2, because index 0 and index 2 we give the value as true, right? Okay, if we go to the next slide, yeah, this is another example. If we have a new array, yeah, like this, then we have the filter. Yeah, we create another variable, and you can just give the name as filter underscore ARR equal ARR modulus by 2. That means ARR is the even number. Yeah, the even number, not the odd number, but the even number. So filter ARR will contain the index. Yeah, will contain the index of the numbers inside our ARR list, which is the index represent the item, the even item, not the odd item. So if we another array here, new ARR equal ARR filter ARR, that will give you false or true. False, true, false, true, false, true, because number one is odd number, so it will give you the false value, and the number two is even number, so it will give you true values, and so on and so on. And we can also create another filter here. So for example, we create a filter which is, we want to get the item which greater than 42, and the new RR will give you the output false or true, based on the ARR variable. If the ARR variable, if the ARR item, in fact the ARR variable is less than 42, it will give you the false value. And if the item inside the ARR array, ARR variable, is greater than 42, it will give you the true value. Okay, that's all from the filtering. It's simple, so I don't need to type it. But actually, this one is the filtering method, for getting the method, getting the item inside our array variable. Okay, that's all from the filtering. And I need, I need to give you the more explanation about this. So if I get the answer, I will explain it by, I will explain it to you by using the Telegram group, about why, how does the short shorten work, and how does the np.new access work, actually, because before this class, I also read some of the documentation, and I understand something, but actually it's not really true, what I understand is not really represent the function of the short shortcut and also the np.new access. So I will give you more explanation after this class, so don't worry about it. But you have exercise, so you just need to complete the following code, to produce the appropriate output. As you can see here, you have 4 question here. Sorry, 3 questions. What you need to do is just completing the code, Okay. So for example, this one, you need to complete this code, and after you complete the code, the output will be, in the number like this. So this is the appropriate output of each question, and this also the second question. You can just understand it by yourself, So you just need to also implement our previous discussion, So it will give you the output like this. And the third question also the same, You can just completing the code, and it will give you the appropriate output. So I also haven't discussed about our previous week homework, because the other class like AP, AB, and C have not finished the homework yet. So I will not discuss about the answer about your previous homework in week 3 homework. So I will discuss it in week 6, because in week 5 you will have a quiz. Actually you already get the email from my Ubaya, So actually you already get the email to have a quiz. In week 5 we will have a quiz, and the quiz will be held on Friday, next Friday. So next week you will not have a class, You will not have a regular class, but you need to work on the quiz. The quiz will be multiple choice quiz, and we will use the Upaya Learning Space ULS, and it will be held at Friday. So the time, I think, if I'm not mistaken, wait, let me check my email. because the email is sent by Vincent, yeah, another lecturer in the data science programming. So yeah, wait, yeah. So I think you already get this email, yeah, and the quiz will be held on Friday, yeah, 11 March, yeah, at 13 p.m. yeah, 1 p.m. yeah. So you need to prepare yourself, yeah, to study from the material course from the week 1 to week 4, and the quiz will be multiple choice quiz. So it's kind of the theoretical quiz, yeah, theoretical question. All you need to do just preparing yourself, and you need to study from week 1 to week 4, and next week, yeah, you will not have a regular class. So you just need to work on the quiz at Friday. But if you cannot attend the quiz, yeah, if you cannot attend the quiz, so you need to fill this sheet, yeah. So actually until this time, there is no student that cannot attend the quiz. So I think it's still okay. But if you have if you can attend the quiz, then you can just fill this form, yeah. So yeah, that's all from my side, yeah, about our meeting today, our class today. Do you have any questions before we end this class? Okay, wait, I will stop my screen share. Yeah, is there any question? Do you have any question before I end this class? Okay, Gabriel, do you have any problem with your internet connection? Actually, you chat on the Telegram group, yeah. You can just you still be able to follow our class today, right?
Yes, but in the middle I got a little bit cut off, sir.
Okay, okay. Yeah, it's okay. Yeah, because you can access the recording video also in YouTube. So I think that's still okay. Okay, if you don't have any questions, so I will give you more explanation in Telegram group because not all of the material course I deliver it correctly. So I will give you more explanation on the Telegram group after this class. But you can just still work on the homework, yeah, and you need to prepare yourself for a quiz for the next week. Will the link for the video for week 4 in the Telegram? Yes, yes, it is. So I will give you the link after this class, yeah. Okay. Thank you for your attention. So I will end this class. We will meet again on week 6, yeah. Okay. Thank you.